All right, starting into chapter 3, we're going to be focusing in on parallel lines. It's really the theme throughout the chapter. If you take a look at the K part, you can see the many terms that we're coming across in this section 3.1. This lays the foundation, really, especially those angles, alternate interior, same side interior, corresponding and alternate exterior for the lessons that follow. Please fill in the notes. I have some parts filled in and I'll do some examples and then complete the rest of the work listed in the folder. All right. Parallel lines are defined as coplanar lines that do not intersect. We're going to use the figure drawn over here to the right. There is a symbol to indicate lines are parallel. I listed it right here. And for example, over in that picture, line BF is parallel to line AE. Right. I will also list one more pair, DC. Line DC is parallel to line AB. Right. They have to be in the same plane. They are not going to intersect. So AB is here, and here is DC over here. Let's go on to skew lines. Skew lines are non-coplanar. They are not parallel and do not intersect. So quite a bit of criterion to meet in order for lines to be skew. They can't be parallel and they do not intersect. So for example, line DA is skew to line BF. So line DA is right here, and line BF is right here. Right? Notice because they are in separate planes, even though they are not parallel, they are still not going to intersect if we were to extend BF or to extend AD. Because they are non-coplanar, they're going to meet both of these criterion. Another example is EF is skew to line CG. Right? You could check that out when you get a chance. Pause the video and even look at it. Parallel planes. So going back to one of the reminders here is how do we name planes? So this figure is made up of some planes. And parallel planes are planes that do not intersect. For example, plane GEF, so as long as we name 3 points on the plane, that identifies a plane, is parallel to plane CAB. That's one example. All right, let's find where that is. GEF is the bottom plane here, and CAB is the top plane. It also includes point D. I could also name a plane with 4 points. So I could say plane ABFE is parallel to plane DCGH. And again, you could go back to the figure and look at that one. Right, here's an example where we're naming some things that we just defined from up above. So I'm going to move to the bottom of the page here. Right, we'll do example 1. Here, problem 1. In the figure, assume that the lines and planes that appear to be parallel are parallel. Which segments are parallel to AB? Those would be segments EF, DC, and GH. Those are segments parallel to AB. Which segments are skew to CD? Here I'm going to take a minute and I'm going to highlight CD over here. And the segments that are skew, there are a couple here. Segment AE is skew. It's not in the same plane. They're not parallel. They're not going to intersect. Segment BF is skew to CD. Segment EH is skew to CD. And segment FG is skew. So I'm just going to take a moment to point out the FG. FG is back here, this dotted line in the back. It's not in the same plane as CD, and if we were to extend either one out infinitely, because they are not in the same plane, they are never going to end up intersecting. What are two pairs of parallel planes? For example, we could say AED is parallel to BFC. Your naming may be a little bit different, but that's okay, as long as you're identifying the planes correctly. We could say plane ABCD is parallel to plane EFGH. What are two segments parallel to plane BCGF? So even though I'm referring to a plane, there can be segments that are parallel to the plane, which are not going to intersect the plane. So those segments are segment AD, segment EH, segment AE, and segment DH. So let's look where this plane is. BCGF. BCGF is kind of the back plane. And I named segments that are segments that form this front plane. So it makes sense. These two planes are parallel, which means any segment on that front plane would also be parallel. All right, so kind of another topic that we're moving on to as we define this term at the bottom, and you can see I filled it in already. The term transversal. Transversal is going to be very important to us as we move on in the next lessons in Chapter 3 as well. It is a line that intersects two or more coplanar lines at distinct points. All right, so we're going to turn the page. In the next page, there's really not a lot of writing, but it's more me just going to give you some descriptions. So we're learning about some more angle pairs, but these angle pairs are formed by transversals. So let's start by looking at what I've already labeled and kind of highlighted in the picture at the top. When we have a transversal, so this is a line that intersects two or more, in this case two, coplanar lines at two distinct points. This is our transversal that I highlighted. We talk about the other lines that are intersected by the transversal as having an interior space in between these lines and an exterior space above or below one of the lines. All right, so this picture we're going to continue to see, and we're going to see it in a little bit different light when we hit sections 3.2 and 3.3. These angle pairs that are defined down here, I've already highlighted some key parts, and we're going to talk a little bit more about them before going on to the final example. Alternate interior angles are non-adjacent interior angles, meaning they're on the inside, the interior part of the two lines, as we showed up above the interior space, and they lie on opposite sides of the transversal. So it's really important when looking at a figure that you can identify your transversal. They give you an example using the transversal with the two lines over here to the right, that angle 4 and angle 6 are a pair, and I will try to highlight them here. They are a pair of alternate interior angles. They're on opposite sides of the transversal and inside in the interior space of the two lines. 3 and 5 are another pair as well. I can highlight those in a different color, 3 and 5. All right. Same side interior. The name helps identify the placement of these angles. Same side interior angles lie on the same side of the transversal. Angle 4 and 5, for example, are a pair of same side interior angles. Corresponding angles. Notice that in the first two definitions, the examples were only 2 pairs, but yet corresponding, there are 4 pairs of corresponding angles in the picture. Corresponding angles lie on the same side of the transversal and in what we say corresponding positions. So let's look at some examples. So angle 1 and angle 5. Angle 1 and angle 5. They're on the same side of the transversal, and notice that they are both above the lines. Let's look at, for instance, another example I'll highlight, 3 and 7. 3 and 7 are on the same side of the transversal, and notice that they are both below their line, so they are in corresponding positions. All right, the final one, alternate exteriors. The word alternate is indicating that they are on opposite sides of the transversal, and they are in the exterior space of the two lines. So I will highlight one example. I will do angle 2 and angle 8. All right, let's go to that last example. You can always look back at this page. These are terms that you are going to need to know for Chapter 3. And beyond Chapter 3. We use these again later on. They come up in some other things that we do. I already have some things labeled in this problem too. Just going back to what was written at the top of the previous page. Recognize which line is your transversal. Your transversal intersects two or more lines. So the transversal I've pointed out as this line R. And then we have line M and line N, which is creating an interior space and an exterior spaces. Right? This doesn't ask specifically for those angles except for the corresponding. It just asks, which angles are in the interior and which angles are in the exterior. So in the interior, we can see angle 2, angle 7, angle 3, and angle 6. In the exterior, we can see angle 1, angle 8, angle 4, and angle 5. The final one is a little more specific. What are the corresponding angles? And corresponding angles have to lie on the same side of the transversal and in corresponding positions. Right? So for example, angle 1 and angle 3. So I'll highlight those. Angle 1 and angle 3, one of the 4 pairs. Angle 2 and angle 4. And then on the other side of the transversal, we also have 2 pairs. We have angle 8 and angle 6, and finally angle 7 and angle 5. If it's not already up, there will be a Quizlet link where you'll be able to practice identifying some of these angle pairs. Please complete the rest of what you were asked within the folder on Schoology. The homework problems which were asked of you are listed at the bottom of these notes, as well as a follow-up quiz, a quick one on Schoology.